All right, welcome back to another exciting and wonderful day in online geometry class. We skipped a bunch of sections in chapter 2. I'm going to basically get the most important parts and sprinkle them through the next few chapters. Mostly what the last chapter was about for the sections that we skipped are things called conditional statements. And that is just a statement that can be written in if blank, then blank form. So if it rains, then the ground is wet would be a non-mathematical conditional statement. If then. Your parents give you conditional statements all the time. If you do your chores, then you can go out. If you get a good grade in math class, then we can go on a vacation on the summer or something like that. The rest of the sections in chapter 2 were about things called converses and contrapositives. And like I said, we're going to cover all that stuff later on. So don't worry about the fact that we are skipping a bunch of sections, but we are moving on to chapter 3. Chapter 3 is going to be talking about proofs and lines, and then chapter 4 we get into our real proof chapter. So here we go. The name of this lesson is going to be relationships between lines. So it says come up with a correct mathematical definition of parallel lines. So if you had to come up with a definition of parallel lines, it'd probably say lines that are close to one another and run alongside of one another or something like that. Some people would say two lines that never intersect. There's a problem with just saying two lines that never intersect. There are different lines that are not parallel that also don't intersect. I'll try to draw them right here. Let's say you had this line, and then you had a line running underneath it like that, like the I-17 and a bridge over the top or something. They don't intersect, but they're also not parallel. Okay. So the real definition of parallel lines is going to be lines that are coplanar and do not intersect. All right. So let me go ahead and show you some examples. Let's say we had this line, which was AB, and we had this line, which is CD. Okay. As you can see, they're roughly parallel. Let me show you how on the diagram you can show they're parallel. If you had line segments that were congruent, we talked about just putting little tick marks on there, and then you would know they were congruent. If you want to talk about them being parallel, you put a little arrow, and one arrow. Then if you had two other lines that were parallel, it would be two arrows and two arrows. And other lines that were parallel in the same diagram, three arrows and three arrows. Okay, so that's how you do it. Now the notation would be AB, the line AB is parallel to CD. That's the symbol for parallel right there. Skew lines are non-coplanar lines that don't intersect. So I gave you an example of that, like the I-17 and then a off-ramp that goes over the top or something, a bridge that goes over the top. They're not actually intersecting, but they're not parallel. Now, the word non-coplanar means both of these couldn't fit on the same flat surface. It's impossible. When I say coplanar for parallel lines, both of these could fit on the same exact plane. Okay. Parallel planes are planes that don't intersect. You can't have two coplanar planes unless they're the same plane. That doesn't make any sense. So let me go ahead and show you an example. That plane and a plane hovering right below it would be parallel planes. And you would use the same exact symbol here. It would be like plane ABC is parallel to plane DEF or something like that. Same symbol for parallel. Alrighty, so that is parallel, skew, and parallel planes. So if we have this, and it says, here's our figure. We've got a bunch of planes. Some are parallel, some are not. We have lines, some are parallel, some are not. It says, what are the lines that are parallel to AF going through E? Here is AF right here, and here is E. What is a line that is parallel to AF through E? Well, let me go ahead and extend this out so you guys can actually see it. Actually, let me just zoom out. There we go. Okay, so you can see that it is EJ. EJ would be parallel to AF through E. Parallel. Okay, next, what is skew to AF containing point E? What is an example? And I'm only going to do one example here. So skew. Here's our line. What is another line that's not parallel, but doesn't intersect? How about ED? That would be an example. EC would also be an example. EB, there's many, many examples of lines that would not intersect it, but are also not parallel. That's what skew means. Lines that are perpendicular to AF through E. Here is AF going through E. Well, I'd love to say that this one was perpendicular. AE is perpendicular. The problem is, I always tell you guys never assume. And right here, they didn't show a right angle marker. Okay, so really, we can't guarantee that's a right angle. Therefore, we don't know for sure it's perpendicular. Now, I want to show you the symbol for perpendicular. Perpendicular just means intersecting at 90 degrees. So if I wanted to say this one was perpendicular to that, this is your symbol for perpendicular. Once again, perpendicular just means intersecting at 90 degrees. That's the symbol. Next one, plane that is parallel to FGH. FGH is this back one. Which one is going to be parallel to the back one? The front one. Plane ABC is going to be parallel to plane FGH. There you go. Notice the symbol I'm using? This one right here is for perpendicular. That one is for parallel. All right, groovy. Hopefully you guys understand the difference between parallel, skew, and perpendicular. Perpendicular is intersecting 90 degrees. Skew is not intersecting but not parallel. And parallel is two coplanar lines that do not intersect. Okay, when we look at this right here, it says, use the diagram to the right to answer the questions. Name a pair of parallel lines. Tell you what on here is going to be parallel to AB? AB will be parallel to CD. Name a pair of perpendicular lines. Well, AB would be perpendicular to what? AC. Perpendicular because they have the right angle marker. Is AB perpendicular to BC? Is AB perpendicular to BC? Is there a right angle marker here? Nope. All right, fantastic. Let's keep moving on. Now here is the big meat of the lesson. The most important part of this lesson is talking about two lines in a transversal. A transversal is just a line that cuts through, that intersects, let's use real correct terminology, intersects two or more lines. So right here, this would be considered to be a transversal. And here would be the two lines that they intersect. So there are different types of angles that you end up being resulting from a transversal intersecting two lines. So here is our transversal. L and M are our lines that are getting intersected. So the first type of angles that we're going to talk about are called alternate interior angles. AIA is a different way of saying it, alternate interior angles. Now let me explain this. This is the interior, and that is the exterior. Okay. Now, being on the same side is talking about being on the same side of the transversal. Being on alternating sides means you're switching. So if you looked at this, it's more directions than anything else. Alternate, switching sides on the interior. What are two angles that switch sides, are not linear pairs, and are in the interior? You would say 4 and 3 are switching sides and they're on the interior, but that's a linear pair. What is an angle along with angle 4 that is switching sides and on the interior? Angle 4 and angle 6 would be an example that says and angle 6. What's another example of alternate interior angles? Angle 3 and what is switching sides and on the interior? Angle 3 and angle 5. All right, so that is alternate interior angles. Here's another one. Once again, kind of like instructions. Alternate exterior angles. Once again, that could be AEA. Well, give me two angles that are on the outside and switching sides. 1 and angle 7. Notice how they're switching sides and on the exterior. And 8 and what's another one switching sides and on the exterior? Angle 8 and angle 2. Those are our alternate exterior angles. Okay, next one would be same side interior angles. Okay, same side interior angles. Here's the interior, same side. Angle 3 and what other angle are on the same side and on the interior? 6. And angle 4 and angle 5. Notice both those are on the same side of the transversal. When I say same side or alternating, I'm talking about the transversal and on the interior, so angle 5. Once again, that could be SSIA, same side interior angles. Okay, the next one is kind of the hardest, not really. This one is corresponding angles. It's the symbol for angles. So what this means is whenever you have an intersection, here's an intersection right here. Looks like this. And it has 1, 2, 3, and 4. There is a top left, a top right, bottom left, and a bottom right. Over here on these ones, there is also a top left, top right, bottom left, bottom right. The corresponding means they're in the same location. So let's say, let me go ahead and back up. Undo. Okay, so let's say we were looking at 1. 1 is on the top left on this intersection, angle 1. What is the corresponding angle? The same location on the other intersection. Top left, oh, this one is also the top left of its intersection, so, and angle 5. How about angle 2? That's top right. And angle 6. But angle 4, bottom left. What's bottom left on the other one? Angle 8. And let's do a cloud. Angle 3. Bottom right. What's the bottom right on the other one? Angle 7. You can call this CA, corresponding angles also. So we had alternate interior angles, switching side on the inside, alternate exterior, switching side on the outside, same side interior, same side on the interior, and corresponding, the same location, either top left, top right, or whatever it is. Hoping that's making sense. So, you know me, I like to make things a little bit more challenging. So what we do is we have this right here. If we were looking at this and we were trying to figure out what type of angles we have here, we are looking at 1 and 9, so I have more lines. So this one and this one could be the lines, and this one could be the transversal, or this could be the transversal. It's basically depends on which two lines you are looking at and what the transversal is. So let's look at this problem. We said 1 and 9. Let me get these markers off. 1 and 9. Here is 1, and here is 9. So that must mean we're talking about only this part right here. Okay, ignore all that for right now. Is that same side interior, same side exterior, or I mean alternate exterior, alternate interior? What is it? Well, it looks like it's top left and top left. So it must be the corresponding angles. Okay, CA. Look at the next one, 8 and 13. Here is 8, and here is 13. It's this intersection and this intersection, meaning we're probably not talking about that. Is that on the interior or the exterior? Well, it looks like it's on the interior of the two lines, and it's the same side. It's the same side interior angles. Same side interior angles. Let's look at 6 and 16. Here's 6, here's 16. It's this intersection and this intersection. So once again, that doesn't do anything. Is it on the interior or exterior? Exterior, because here's the interior. That's the exterior. Switching sides or same side? Alternating sides. So it must be alternate exterior angles. The next one, 4 and 10. Here is 4, here is 10. This intersection and this intersection. That doesn't matter. Looks like it's on the interior and it's switching sides. On the interior and switching sides. Alternate interior angles. Let's look at 8 and 16. Here's 16, here is 8. That doesn't matter because it's these two intersections. It's bottom left and bottom left. Oh, that's going to be, if it's bottom left and bottom left, that's got to be corresponding angles. And then the last one, 10 and 13. This one's tricky. This intersection and this intersection, meaning none of that matters. It's this line, and here's the transversal. So is this on the interior of the two lines or the exterior? It's on the interior. Is it switching sides or same side? Same side. So it must be same side interior angles. All right. Now here is where it gets tricky. This is the hard stuff. So let me go ahead and zoom in. Yeah, that works. Okay, so this wants us to talk about all angles that are alternate interior with 20. Here's 20. What are all the alternate interiors? Well, if I went over and I had this line, and this was my transversal right here, what would be switching side and on the interior? It'd be 20 and 29. So 29 is one of my answers. What about if it was this line and that was my transversal? Then it would be 20 and 21. Is there any other angles that would be alternate interior? Nope, those are the only two. So that's tricky because you have to be able to go over and figure out what are the two intersections, what are my lines in the transversal, and ignore everything else. So let's take a look. SSIA with 30. If this was my line and this was my line and that was my transversal, this is the interior. What angle would be an SSIA with 30? 20. What about if this was my line and that was my line and here was the transversal? It'd be 30 and 8. What about if this was my line and this was my line and here was my transversal? It would be 30 and 33 because that would be on the interior and the same side of the transversal. And 33. All right, let's move on to another one. What about with angle 19? Here is 19. What is a corresponding angle? Well, if it was this line, here's the transversal, bottom left and bottom left. So that would be angle 7. Here is my line, here's my line, and here's my transversal, bottom left and bottom left. This is probably the hardest part. If this was my line and this was my line and that was my transversal, it'd be bottom left and bottom left. Was that 23? And then if this was my line and this was my line, it would be bottom left and bottom left. Okay, we're not going to do these ones. This is a more challenging concept here because once again, you have to figure out what are my two lines, what's my transversal, and ignore everything else. So I want to do it one more time. Let's say we had, I don't think it's going to let me do it. Anyways, once again, if you figure out that you're going to talk about these two lines and here's the transversal, you have to ignore everything else. All right, hopefully that made sense. Think of each segment in the particular diagram as a line. Complete the statement with parallel or, let's take a look what we have here. Parallel, skew, or perpendicular. And we're assuming all these are right angles. Okay, so WZ, and ZR. Do they look like they intersect at 90 degrees? They don't intersect, but they're not parallel, or they're parallel. Looks like they are perpendicular. They intersect at 90 degrees. WZ and ST. Ooh, those look like they're parallel, right? Because they don't intersect, but they are coplanar. You could have a flat surface that contains both of them. Parallel. How about XT and YS? Ooh, those don't look like they're parallel, but they definitely don't intersect, so they must be skew. Skew. How about plain WZR? WZ and R is the front, and SYZ, SY and Z is this side. The front and the right intersect. It looks like they're perpendicular. They intersect at 90 degrees. And the last one, RQT. RQT is the bottom, and YXW. YXW is the top, so they must be parallel. All right, we got one last page we got to take a look at. Okay. Okay. So what is a line parallel to EH? I'm going to give an example of each one of them. EH, what is one line that's parallel to EH? Would be AB. Okay. Next one, perpendicular to EH. Here's EH. Something perpendicular to it would be EA. Skew to CD. If you're a CD, what is something that is not parallel but doesn't intersect? How about FE? Oh, containing F. So yeah, FE. Planes perpendicular to AEH. AEH, that's the bottom. What is something that is perpendicular? Let's only do one of them. How about AED, the front? Plane AED. And then parallel to FGC. FGC looks like it is the top. What is parallel to the top? The bottom. Plane EAB. Hopefully that's making sense. Let's wrap it up. Okay, last one. These are the hardest ones. Sometimes, always, or never. It's a 1 in 3 shot that you're going to get it right, but if two lines are parallel, then they blank intersect. Never. It's impossible to intersect. If one line is skew to another, then they are blank coplanar. Skew lines, a plane that contains that, this one would shoot directly through. Plane that contains this one, the other line would shoot through. So if one line is skewed to another, then they are never coplanar. It's impossible. It's part of the definition. Next one, if two lines intersect, then they are blank perpendicular. Is it possible? Yeah. Is it guaranteed? No. What is it if it's guaranteed, or it's not guaranteed, but it's possible? Sometimes. And the last one, if two lines are coplanar, then they are blank parallel. If two lines are coplanar, are they parallel? They can be, or you can have two lines that intersect that are on the same plane. So sometimes. All right, that's that. Just make sure the most important part is you can identify alternate interior angles, same side interior angles, corresponding angles, and alternate exterior angles. When I was taught this, I also had alternate, same side exterior angles. They don't have it in our book. So there you go. That's the lesson. Thanks for watching.